Wait, hold on. What do you mean not like me more? Are you insinuating she already doesn't like me?
Well, if you're arguing...
Well, you always
Morgan,
insult him.
I said discuss. There's a difference.
Morgan, you're in the way of the camera.
Is that
Okay.
99.2 kPa?
99.2 kPa. So, to balance this out, we're going to need a 2 here and a 2 there. Or, if we want to be slick,
Let's not be slick.
we can put a half there. Let's do it.
Sure.
All right, so we have 2.51 grams of silver. What are we trying to find? Volume of chlorine. Is this a limiting reactant problem? No, why not? There's only one amount for one reactant. Okay, they just give us the silver. So this is kind of more of a regular stoichiometry problem. Start with the silver. That's our known. What do we need to do? Get it to unknown. So what does 1 mole of silver weigh? 108 grams. Once we have it in moles, what would our next step be, Brenny? Yep, the ratio. So here's my ratio is 1 to 1/2. So for every 1 mole of silver, a 1/2 mole of chlorine. Now normally, if we were doing this back with regular stoichiometry, we then convert that to grams. But since we're doing gas laws, we're going to stop right here and find the number of moles. And I get 0.0116 moles of chlorine gas. Now that I have my moles, I can plug it into PV equals nRT. nRT over P equals V. I have my moles. That's N. In the last problem, we used PV equals nRT first to find the moles, and then we did our mole ratio. In this problem, we're getting the moles, and then we're plugging into PV equals nRT. So you can have problems do it either way. You can be using PivNert first to find the moles, and then you do your ratio, or you could be doing a problem where you do your ratio first and then you find your moles. Temperature is 24 Celsius plus 273 equals 297 Kelvin. Plug in our moles times 8.31 liters kPa per mole Kelvin. Let's read that. Use the 8.31 because we're dealing with kPa, and our temperature is 297.
What would we use if we're not dealing with kPa?
Then use the 0.0821 liters atmospheres per mole Kelvin. And I come up with a volume of 0.287 liters of chlorine gas.
You did 0.289, that's what I got.
Yeah, it's
That's what I
289.
got. 0.289. Yeah, that's what I got.
Sure you didn't know.
You get 0.2
Yes, you're right, with another sig fig over.
That's 8 in one period.
I'm just, now it's for all the world to see. So, there's my volume. Again, if you were at STP, you could skip using Pivner, or you could just do that.
Mr. Strauss, do all your classes? Do all your classes usually get all of the 1,000 points for the semester party or regular
Yes.
years?
Yeah.
Really?
Yeah. Some years a little bit better than others, but usually we always break 1,000.
Have you ever not?
No, Morgan, thank you.
Oh.
Would you like to give me a paper cut and put lemon juice in it too?
I'm sorry.
It's alright.
Did you, when you were planning our days, did you give us a day for a party?
Yes. I figured I would break it. Okay, so we'll have the party on Monday.
So the party could be Thursday and the test Friday.
How's that sound?
Well, what if we don't make it to the fun part?
Will Grace bring the food?
Grace will bring the food. We have it on tape.
She's not-
By the way, Monday's a late start.
No.
We'll probably have it next week Friday. We'll see how this week goes. Either this Friday or next
We
week.
should have an outdoors party. We grill and stuff and study the reaction.
Okay.
Miss Hammer's gonna take
Um,
the now.
Here we go. Find the volume of gas.
Show us which problem is this?
I'm just making this one up. Find the volume of gas.
What kind of gas?
Doesn't matter.
We need the ideal gas law for everything going into universal.
What if you need the more mass?
806 liters at 29 degrees Celsius and 0.589 atmospheres. When the pressure and temperature are changed to STP. So find the volume of gas of 806 liters at 29 degrees Celsius and 0.529 atmosphere when the pressure and temperature are changed to STP.
I don't know if it's a question, it's more of a
I know.
statement.
It is. So, our volume is 806 liters. Our temperature, 29 degrees Celsius. Our pressure is 0.589. Our new pressure, so if we have a new pressure, we must have a P1 and a P2, right? The new pressure is STP. What's the pressure?
One
Where's the
atmosphere.
units on P1?
One atmosphere.
Yeah.
One atmosphere.
Oh my god.
One atmosphere.
1 atmosphere. Right? Because standard could be 101.325 kPa, or standard could be 1 atmosphere. Either one.
Yeah, that was a mistake.
10 in one class, right?
Oh
Ouch.
boy.
Almost there.
Thus you're unraveling.
We're changing the temperature to standard temperature, which is 0 Celsius, or 273 Kelvin. So we have a T1 and a T2, we have a P1 and a
You want
P2.
still in degree
That's really, I am really unraveling. I guess I can't handle being broadcast in front of millions of viewers.
Was it?
Stage fright. Because there will be a million hits.
You
I
get, like,
no doubt
hobbies.
that by the end of today,
T1 is still in
I'm
degree
gone viral.
Celsius.
T1 standard.
T1 is in degree Celsius.
yeah, we haven't switched it yet.
Just
So
let you know.
we have a V1, we're trying to find a V2. Temperature must always be in Kelvin.
Not
Okay?
degrees Celsius.
So don't get mixed up and put these in like this. Okay, temperature must always be in Kelvin. So we're gonna have to add 273.
302.
302.
I was getting
I even said it aloud. Oh my god.
wow. So, what equation are we going to use here? Are we doing stoichiometry?
No.
No, there's no equation there, so we shouldn't be doing stoic. Are we doing a limiting reactant problem? No. Of these four equations, which one should we be using? Combined gas law. Okay, so where it gets a little bit difficult sometimes now is when you're trying to take all of these different things and no one says, oh, use this equation here, use this equation here. So, like I said, go back and rework these problems tonight, the ones that you didn't get. We'll go over them tomorrow.